My name is Scarlett Simmon, and I'll be talking about Lab 1, Constant Velocity. So first of all, here are the topics being discussed in order. I'm going to start with introduction, go through some basic physics principles, show the procedures, the data analysis, possible errors, and then address some further questions. So first of all, the purpose of this experiment is to compare the observed position of a moving object traveling at a constant velocity to a computational model that predicts the position of the object. For the experimental model, I used Tracker to map the position, and the computational model is done on GlowScript. Some physics principles will be described on the next slide, but just to preview them, we will be talking about net force, velocity, and position updates. And then the main goal of this lab is to demonstrate the principles of Newton's second law, which is that zero net force results in a constant change in momentum over change in time. So here are some of the physics principles that I'll go into in more detail. First of all, in this experiment, the system is the tape roll used. The surroundings are everything else, including ground, air resistance, gravity, friction, and other unknown forces. The net force is the sum of all the forces acting on a system at a given moment. In this lab, the net force is assumed to be zero because there is assumed to be no net force in the x direction. I'll go into why this might not be the case in a little bit. And then Newton's second law is also known as the momentum principle, and it states that the net force on an object is equal to the change in momentum over change in time. And these are these three formulas below. So the procedures: first, recorded a video of the tape roll rolling in a straight line in front of a meter stick for perspective, and we uploaded it to Tracker. At that point, I tracked the roll's position in each frame at set time intervals. Then, using GlowScript, I created a computational model for the position, and then used Google Sheets to compare the two, and then, again, compare the models and draw conclusions. Hello? Sorry. Some observed positions in Tracker. Oops, sorry. Yeah, so on the left here is the video that I tracked. On the right is the position time graph of the X and the Y. As you can see, the Y looks a little crazy. That's just because, like, when I was tracking each individual frame, it was hard to keep it level, but that's ignored for this. And then in the bottom right was the data that Tracker gave me. These are my initial conditions. I chose 2 points near the beginning, so 3.02 and 3.12 in their corresponding positions. And then I did the change in displacement over change in time to find an initial velocity of 0.685. And then for ease, I rounded this to 0.7 and updated the code below. The velocity vector in the x direction should have been 0.7. I also updated my t because around 3 was where my frame started in the video. More code: change the net force vector to 0 as before mentioned, and then change the velocity position formulas to the velocity position update formulas in order for the iteration to work correctly. Then I graphed the Tracker data and the GlowScript data. As you can see, they were very similar. Near the beginning of the graph and the end of the graph, you can see those blue dots kind of stray from their line of best fit, but overall very similar. A little bit shifted downwards or shifted upwards for the GlowScript data. And this is probably because some of the things I will mention on the next slide, which is outside influence like friction, air resistance, and possible slant of the surface, which were not included in the calculations because we calculated the net force as 0. And then tracking issues. There could have been issues when tracking the tape roll because it was kind of blurry in the video, so it was hard to identify the center of mass. Here are some further questions. So if the x-axis were flipped, then as you can see from this arrow, the blue arrow is kind of the coordinate system that I designated using Tracker, that the right position was positive x. So the magnitude of that would be the same if x and negative x were flipped. The only difference would be the direction. So the position time graph would have the same slope and therefore the same velocity, but it would be in the opposite direction. And then what does it mean that the net forces of the forces is 0? Basically, we don't know every force that went into making the net force 0. We can guess, but again, there are outside influences such as air resistance and friction that we did not account for. So we can't account for everything in this experiment about the net force. Thank you.